Good afternoon, folks, and welcome to our virtual tour of outer space. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences, and today we are not at the California Academy of Sciences. We are beaming straight from our houses to yours. Now, for our virtual tour of outer space, it's a very cool program for us to kind of get away from our day-to-day lives here on planet Earth and go off and visit some other really cool spots. You can see Earth hanging out right there in our OpenSpace software. Now, OpenSpace is a really cool software. It's something that you are able to check out too if you are a fan of planetariums and planetarium shows. Our OpenSpace software you can actually download on the openspaceproject.com if you want to try it out for yourself. And today, our program is partially funded by NASA. Our friends at NASA are really interested in knowing what you think of the program. So if you have an opportunity, fill out the survey at the very end of the program and let them know what you thought. First 30 people to complete the survey get a NASA logo sticker in the mail. That's a very cool meatball, the classic logo. And we'll give you a link right there on the side. Okay, so with that, let's start off with our very own planet Earth and see what is happening today. Now, looking around on planet Earth, you can see some light stuff and some dark stuff. You got bright white clouds, blues, they're both light and dark, as well as some lights of our human civilization right over here. But as beautiful and wonderful as our planet is, it is a place with some difficult stuff going on. I would be remiss if I did not mention the fact that here in California, and in fact all along the West Coast, we are experiencing some pretty profound fires. Now, you can actually see those fires in our images today because these are not archived images taken many years ago. You can see our planet changing in almost real time. All of these hazy gray areas with little individual fingers reaching down to touch the planet, those are where we see our wildfires here in California, through Oregon, Washington as well, and you can see just how far that smoke is extending. Now, these are photos captured around noon yesterday. The situation is different today, and if you want to find that out for yourself, download OpenSpace and check out the West Coast. So it might seem a little scary. It might seem a little dismal and downtrodden when we're looking at our planet like this and seeing the profound effects of those wildfires. But remember, satellites like this also help scientists and firefighters on the surface of planet Earth understand the extent and how to better fight these fires. So it is a little scary for us to see the effects, but honestly, for that, all we have to do is look outside our window. And another wonderful part of a program like this is that it gives us an opportunity to remind ourselves that there is an entire planet out there, that these fires don't extend to every single place. And beyond even our planet, there's a wonderful, beautiful galaxy that we can see just our tiny corner of out here. Now, we're not going out to quite the galactic scale yet. We are mostly hanging out inside our solar system and the area around it. But if there is a place nearby that you would like to see in our program today, please let me know. I am always excited to go visit some spots that guests have suggested. Now, on our feed today, someone said that it looked just like we were on Mars when we looked outside our windows here in San Francisco. I can see why people say that. You can look out and see that weird, hazy orange sky, and Mars is the red planet. Part of that does come from the atmosphere. So let's look down at the surface of Mars and see what it looks like when you're on the surface of Mars. Now, on the surface, you can see a couple of those cool features. We've talked about in many previous weeks our volcanoes on Mars. The volcanoes are absolutely exceptional. You've got Olympus Mons up here, the rest of the Tharsis Plain. Beautiful, gigantic peaks, to be sure. You can see part of Valles Marineris right here, and actually the extent of the Martian atmosphere kind of pooling, almost puddling inside that deep fissure on the ground, allowing us to see the thickest parts of Mars's atmosphere right down there where it fills in. Okay, now let's fall onto the surface of Mars, and as I do, I'm going to change our angle just a bit so that we can sort of imagine ourselves landing on the surface. Here we go. Now, coming down onto the surface of Mars, you can see that atmosphere beginning to fill our view. I gotta say, that does look a little familiar. Wouldn't you other Californians agree? Looking out there, that kind of orangey haze. Okay, so maybe the people who say it looks like we're on Mars have a point. This is definitely an orangey place. You can see some of the stars popping through. That probably wouldn't be true on the daytime side of Mars. Mars's atmosphere is a little thicker than would allow us to see stars right through it. On the nighttime side of Mars, though, you absolutely would, and with very little flicker. Maybe building observatories on Mars would be a good idea one day. But I suppose if you're going through all the difficulty of building an observatory, you might as well just build it on the moon, because the moon has no atmosphere to block your telescope's view. Okay, so looking down on Mars, I would suggest that looking in some other spots might give us an also very Earth-like view. If you want to check out photos of Titan taken from the Cassini mission, you can see a very similar atmosphere to at least the colors I'm seeing outside my window. Now, atmospheres are pretty special things. They can change a planet pretty much entirely. And for another really interesting atmosphere, I almost said cool atmosphere, but cool does not describe this atmosphere. We are heading to Venus. Now, landing on the surface of Venus is something human missions have done, and that we've sent probes, robots, to land on the surface, but there are never any humans on board. Why is that? Well, first of all, humans haven't landed on any other planet, but secondly, it would be a really mean trick to play on astronauts to tell them they were blasting off to go land on another planet and then to land them on Venus, because they would probably melt. And in more ways than one, Venus is a pretty toxic spot. Its atmosphere is almost entirely carbon and not at all good for human beings. It's very high temperature, so it's around 700 degrees on the Fahrenheit, 900 degrees on the Fahrenheit scale. That is super hot. My friend Bing often says that it's about the temperature to melt lead, or potentially the temperature of a pizza oven, neither of which sounds like good places for a human being. Now let's check out the surface of Venus. I'm going to drop us down in, just like we did from Mars, and let OpenSpace tell us what the atmosphere might look like from inside. Ooh, this looks creepy. Okay, settling down into the clouds of Venus. We've got that weird hazy yellow, maybe tinged with blue. This is a very different kind of place than we would have here on Earth. And the most interesting part is, well, once we got completely under that atmosphere, you wouldn't see much at all, because that atmosphere blocks light. Very little light would get down to the surface of Venus, so it would be a dark place. Some people imagine there might be stuff like lightning storms. That would look pretty cool. But if we want to see the surface of Venus, we have to imagine looking in a very different kind of way, because if it was pitch black, you just wouldn't see anything. But we can actually do a radar map, show you a little bit about what the surface of Venus would look like by just pretending it didn't have an atmosphere. Now, there we go. This looks orangey, because that is about how we imagine the surface of Venus, with that little bit of light sneaking through. But in actuality, the rocks themselves are gray. Now, why gray? Well, it turns out that most of the rocks in our solar system are gray. If you want to prove it to yourself, imagine the moon, gray rock. Imagine any asteroid, gray rock. Mercury even is gray rock. Let's check that out next. Would you believe me if I told you Mercury and Venus are the same color rock? It's true. They're both gray rock. So why does Venus look so different? And to answer a question we had earlier, why is Mars red? Well, it turns out it's mostly that dusty color on the surface. Salini asked, why is Mars so orange? I would say the orange is probably a little bit from the atmosphere. The reddish color comes from a lot of that iron oxide on the surface. When we think about iron oxide, we often think about dust. I want to fly to Mars, because if I'm talking about Mars while I'm looking at Mercury, I'm going to confuse myself and probably some other folks. But when we're looking at Mars, we see that reddish color, we think rust, iron oxide. Now, I lived in San Francisco, out by the ocean. And when I saw metal that had a reddish orange color, it was rust, because next to the ocean, everything rusts. It rusts from salt water hanging out in the air from all of our wonderful San Franciscan fog. So is the red dust of Mars evidence of oceans? Maybe in the ancient past, when those oceans dyed the whole surface red? Probably not. When we look at the dust of Mars, it's probably bonded in a very different way. It's not the presence of water that created rust. It's carbon dioxide with those iron compounds, making that rusty surface. So I shouldn't call it rust. I should call it iron oxide. But that reddish color does come from the dust of Mars. And if I were to blow on the surface, you would see that same gray rock. Corey wants to know why scientists think Venus and Mercury are composed of similar materials. They're composed of the most common rocky materials in our solar system. When you look at the average color of rocks across our solar system, they're gray. In fact, while each planet might have its own differences in composition, at a base level, we're all made of rock, which is silicates, and we're made of iron, which is ferrous materials. Those are very common materials in our solar system and in others. They seem to be the products of the death of stars, certain kinds of stars, and those are very common stars. And they make a lot of those materials. So just across the universe, you're going to have a lot of that kind of material hanging out. So if you were building a solar system, you use the most common materials around, you end up with a lot of planets like ours. We can see that in some of the rocky outer worlds too. The farther we go from the sun, the rarer a rocky surface becomes because we get things like ice. Now, we're flying out to the very biggest moon in our solar system. In fact, it's pretty much a planet-sized moon. This is the moon Ganymede. Now, when we get to Ganymede, it's got a very similar looking surface, but this is probably an icy surface. There's probably rock underneath. In fact, there might be some exposed rocks somewhere on Ganymede. But again, we're seeing that same grayish color. It's just the color a lot of these objects tend to be. Now, when we look around on the surface of Ganymede, you can see icy cracks and fissures. It's a world worth exploring for no other reason than, well, I'm a big fan of TV shows like The Expanse. They spend a lot of time on Ganymede, so I really want to know more. But if we're talking about rocky-ish worlds in our solar system, objects similar in size to Earth, this has to be on that list. It's much closer in terms of volume and size to Earth than it is to its planet Jupiter. Jupiter is gigantic. We have very little in common with Jupiter. We have a lot in common with Ganymede. Elizabeth wants to know, a few days ago, there was a big explosion on the sun. Elizabeth, I'm going to answer your question in the most useless way possible. Yes and no. Yes, the sun always has tons of activity because the sun is a giant incandescent mass of iridescent, a giant incandescent, what is it? Incandescent miasma, a giant miasma of incandescent plasma. There we go. That's the song I'm looking for. As a miasma of incandescent plasma, we are seeing the sun's surface glowing, and that glow comes from energy. The energy comes from a process we call fusion. Fusion is ongoing inside the sun, and that is basically the most powerful kind of explosion you could ever imagine. That energy is transferring out through the layers of the sun, but it takes a long time. One little photon gets shot out, absorbed, shot out, absorbed, shot out, absorbed, shot out, absorbed in random directions over and over again. So it might take a very long time, millions of years, for one little bit of energy to reach the surface of the sun. That's the day-to-day for the sun. Totally average, minute by minute, we are seeing energy that was created millions of years ago from these powerful fusion events radiating out from the surface. But when something unusual happens, and I think that's what you're asking, a few days ago there was a big explosion on the sun. We get a lot of solar activity at different times. Now, if you want to find out what's going on the sun, there's an awesome place to check out that is called SDO, Sun Today. And if you go to that website, they can show, the Sun Now. They can show you a minute by minute, day by day, week by week version of what's happening on the sun. And if you comb around on there, you might be able to see kind of what the sun's been up to. I haven't seen anything pop out as a huge and noticeable change on the sun, but that doesn't mean that something didn't happen. We're often kind of monitoring the sun and seeing what's going on. A while ago, there was a lot of cell phone inactivity on planet Earth, and people were keen to blame the sun for it. Unfortunately, it looks like that was people messing up cell phone networks and not the sun messing up cell phone networks. So I'm checking over the past few days, and it looks like our K index, which is telling us about the weather of the sun over the past little while, we haven't had any major spikes. So I would say that hasn't been a big burst of activity on the sun recently, other than the incredibly normal day-to-day giant explosions that power our star. Hope that gives you some context. Okay. Let's pull back a bit. A question about the two black holes that collided. Gosh, you're putting me on the spot. When did black holes most recently collide? I know we had a really cool observation of them that gave us our LIGO result. That was an interferometry laser experiment that told us a bit about how gravity waves work in our universe. For two black holes that collided more recently, I would need to go check some science blogs and see if I can figure out exactly what story you're talking about. Okay, diving back into our solar neighborhood. Thankfully, we don't have one black hole, much less two hanging out around our star. Let's see if there are any other suggestions. But if not, I'm going to finish my point about Mercury, because I think this is absolutely fascinating. So in geology, we have a really cool principle that says that if two objects have a similar enough composition, it probably means they were once part of the same object. Now, we call that uniform composition, I believe, is the principle, but I'll ask my friend Jen for the specifics. If I find a rock and it's got 10% of one element, 11% of another element, 2% of one element, and 0.5% of another, and 4 or 5 of those things are a perfect match with another rock, that would give us some really cool insight that both of those things were probably one thing at one point. Now, when we're looking at Mercury, we can see that it's got a grayish composition. If we were to compare it to the rocks of Venus or the rocks of Earth, we would see they were close, but not a perfect match. Mercury, I think, overall has more iron than the rocks of Earth or Venus. Now, when we're talking about this principle, it actually has a really cool story to tell about the history of our solar system, and it's a story that brings us actually very close to home. It's the story of Earth, that cool little blue planet we're flying past, and our moon. When you look at the moon and compare it to Earth, we are a super close match. Earth and the moon are made of the pretty much exact same ingredients. And when you start putting that through that principle of uniform composition, well, that means we were once part of the same object. We're too close to have been separate. So now the leading theory about where our moon comes from is that Earth and the moon were once part of one giant debris cloud. Probably that debris cloud formed after two objects collided in our early solar system. Some people like to call it a proto-Earth and a proto-moon. But when we talk about a proto-Earth and a proto-moon, that supposes one was one and the other was the other. They both come from the same debris cloud, I think is the safest way to say that. Okay. Oh, my favorite moon. What is my favorite moon today? We've already visited several of my favorites. So I'm going to visit the one of my favorites we've not visited. Let's go to Europa. Now, this is our second trip to the Jupiter system, in which I've not spent any time talking about Jupiter on either of them. Jupiter system, you're talking giant gas ball. Got these amazing moons. Right. Now, jumping down onto the surface of Europa, this is not a world with an atmosphere. I'm going to say world so I don't mistakenly call it a planet, because Europa is very similar to a planet. Looking around on the surface of Europa, you can see these cracks and fissures, which I just think are the coolest thing to look at. I feel like I'm always worried I'm boring the audience with looking around on the surface of Europa, but I think it is just fascinating beyond compare, and it is too easy for me to just stay fixated. So looking around here, you can see these cracks and fissures, straight lines. That's really unusual to see a line as straight as some of these in space. Often when I see a straight line, I think it's my computer struggling to download an image like this one. But on Europa, sometimes that's the system working. You can actually see those cracks that are lunar features on this distant world. Here's a perfect example of what I'm talking about. Okay, so look around here. See these winding bends? There's a nice crater there too. I can see this curvy line and then this straight line. And the curvy line is overlaying the straight line. It's top of it. That tells me that the curved line is newer than the straight line. The straight line was already there when the curvy line showed up. But then you can see that this like terminates. There's a crack here where something shifted, something moved. We get a lot of that on Earth. In fact, in San Francisco, we live on a feature like that called the San Andreas. It's a fault. A fault is where there's a broken thing, a a broken solid thing like rock or ice, and it's moving. Now, those faults cause earthquakes here on Earth. You can't have an earthquake on Europa. Maybe you could have a Europa quake. I would be very interested in finding out if that happens. We know there are moonquakes and Marsquakes, though, based on the instruments we've left behind on the surfaces of those worlds. So quakes seem pretty common, and Europa is an active world with a lot going on. I'd be kind of shocked if there wasn't some kind of motion there. Ooh, we got a request from Makemake. I cannot show you Makemake because I don't have Makemake loaded up, but I can tell you there are some great photos of Makemake. So if you are interested in that kind of object, you're going to want to head online and see some of those really cool shots. I'm zooming back to see if I can maybe show you an orbital line for Makemake, but I'm not holding out too much hope. Makemake is in this software, so if you want to download it and add it in yourself, you certainly can. But I think the dwarf planets I have loaded are pretty much limited to Pluto. Now, how can you tell which one of these lines is Pluto? Our engineers downstairs were kind enough to help us out by making two of them different colors. So you can see a pale blue line right here and a pale blue line right here. These orbit lines show us where a planet has been, so we can tell where a planet is going. Now, the brighter the line is, the more recently the planet was there. And as we go back farther and farther, you can see that it fades away to pretty much nothing, but we can tell where that planet will end up next. When you look at these pale blue lines, there's one between Mars and Jupiter. That's Ceres. Ceres is an asteroid. It's also a dwarf planet. It is the biggest object in the asteroid belt. And we can also go check out Pluto, this outer dwarf planet. There are other dwarf planets. Makemake, I believe, is one of them, so that would be a cool object for us to show off next time. I can tell you I will do my best to add it in for our next show. Okay, now to show you the picture of dwarf planets, I'm going to limit us to Pluto and Ceres, but I will do my very best to show you both of them. Kind of a cool thing. It looks like I've got Pluto impaled on like a toothpick right here, like the line went through it. In fact, the line goes right in the direction of Pluto's big moon, Charon. Now, this is not an accident. This is actually the point right between those objects that they are both orbiting. Turns out Pluto orbits Charon and Charon orbits Pluto. They are two peas in a pod, as it were. And I think they might also be objects with a uniform composition, telling us they may have been one object at one point. Now, looking at Pluto, you can see that smooth, swirly white surface. Absolutely beautiful. Icy like Europa in some spots, but very different in others. This spot right here we think is a nitrogen glacier on the surface in that it is pretty much devoid of craters. We just don't see any craters hanging out on that surface. You can see big craters down here, though. This is likely an older surface, and it's not in shadow. That's the color of the surface is very, very dark. A huge contrast to these lighter parts over here. We can even see some very similar stuff on Charon, and I think we should be adding Charon to our dwarf planet catalog too, but that's a somewhat controversial opinion. Can a moon be a dwarf planet? Can a dwarf planet be a moon? Who knows? The IAU probably, but they have some muddy waters in their categorical systems. And I think whatever we call Pluto, we should be calling Charon too. Its surface is amazing. You can see this gigantic cliff face here that separates two different kinds of terrain. This very lumpy, bumpy stuff over here. Check out those mountains on the side. That's not my computer failing to draw the geometry. That's the actual geometry. It's got this big flat part here and these bumpy parts over here, and then a much smoother area with this giant peak poking out right there. Now, if you look up the surface features on Charon, you will see some very entertaining names, especially if you are a fan of sci-fi and fantasy. Okay, I promised you more exoplanets. Let's go check, or excuse me, not exoplanets, dwarf planets. Let's go see another dwarf planet, my buddy Ceres. Now, in our school shows, we like to have kids talk about planet names and what they know about planet names. Ceres is a cool one to talk about because everyone likes to eat breakfast cereals, right? Cereals. Breakfast cereal comes from cereals, which are grains, and Ceres is named for the Roman goddess of the harvest, the Roman name for Persephone, Demeter. When you look around here, you can see this is not a very verdant area, though. It's that same bumpy gray rock we mentioned before, and this one, like Earth, has a high ratio of water inside it, In fact, it probably has a higher ratio of water to rock than Earth does. Recent evidence suggests we have a watery Ceres, which means a whole bunch of material inside it that we would classify as water, and it might actually have more water material inside it than we do on Earth, although it might be in a somewhat frozen form. There's a lot of discussion about what model of the amount of water is actually correct for Ceres. Okay, fading down our planet trails, because I'm not talking about that anymore, and I don't want to confuse people about why is there a giant bowl of blue spaghetti hanging out in our solar system. Okay, so backing up a little more, I mentioned these things by accident, and I want to make sure I mention what they are. I said exoplanets. Now, exoplanets, for those of you who have been tuned out of astronomy for a little while, are one of the really cool, really exotic and wonderful things in astronomy. They are planets around other stars. Now, this is a wonderful set of discoveries and really important one because it helps us contextualize our solar system. Something I like to say to people is everything we know about solar systems, we learned pretty much from our solar system for most of astronomy. Through 1995, everything we knew about solar systems, period, was by examining our one solar system. And our solar system, we assumed, was an average one, but we didn't really know that because we didn't know of any others. So imagine you're an alien and you come to planet Earth and you want to learn about life on Earth. So you grab one life form. Let's say you grab a cheetah, and everything you know about animals you learned from that cheetah. So all animals are spotty. All animals are super fast. All animals are long, stringy cat-like creatures, even though you wouldn't know the word cat. But that's what you would think of all animals. When you learned about a sloth, you'd be pretty surprised. But by examining a cheetah and a sloth, you still have some biases. You need to examine some beetles, depending on who you ask, some viruses. You need to examine every single kind of life you can to really contextualize the one kind of life you started with. We need to learn more about other solar systems because everything we know about these solar systems passes heavily through a lens of our solar system. If we want to really understand these other places, we need to learn as much as we can about them because who knows what insight we will gain from another solar system that'll put our own in context. So that is just such an important and amazing part of astronomy today. We are finally hitting a point where we have kind of a survey of what kind of solar systems are out there, and we are just about to begin the process of really studying them in depth. Now, at Morrison Planetarium, we've been thinking about this a lot. We're writing upcoming shows that tell us more about the search for other planets and how we learn about them. It's going to be some pretty exciting stuff. So I hope you all stay tuned. And when we are able to return to museums and do cool stuff like that, we hope to see you around. So that, I think, is pretty much our time for our show today. I'm going to start taking us back into what is currently my favorite planet because it's in kind of some dire straits right now. That is planet Earth. But on the way in, I would like to thank all of you for tuning in, for sharing your afternoon with us. I hope that by tuning in and flying around our solar system a bit, we've given you at least a little bit of a reprieve from all the stuff that's happening out there, our own orange skies, and reminded you that there is a big and wonderful universe out there just waiting to be examined. So on behalf of myself, Morrison, our friends at AMNH, and OpenSpace, we'd like to thank you for joining us. If you have the opportunity, fill out that survey. Let us know what you think of this and other programs like it. And if you're one of the first 30 people to do it, you can get a really cool NASA sticker of your very own. So with that, thank you again for joining us. Have a wonderful rest of your day. Stay healthy.